You have probably used ChatGPT or Claude at some point. You typed something in, got a response that was kind of okay, maybe tried again, got something slightly better, and eventually just did the task yourself. But did you ever stop to wonder, was that the model failing or was that the prompt failing? Because here's the thing, two people can use the exact same AI model, give it the exact same task, and get completely different results. One person gets a vague 3-line answer, the other one gets a structured, accurate, and production-ready output. The model is identical, so the difference is entirely in how they communicate with it. That skill has a name. It's called prompt engineering. And once you understand it properly, your relationship with every AI tool you use changes permanently. So what's actually going on under the hood? A language model does not understand you the same way a human does. It's not reading your intent, it's doing something much more specific. Predicting the most statistically probable continuation of the text you give it. That's it. That's the whole entire mechanism. Which means the prompt you give it is not just a question, it's the entire context the model uses to decide what to generate. The structure, the clarity, the framing, all of it shapes the output before the model generates a single word. Prompt engineering is the discipline of designing that input intentionally. Before we talk about techniques, let's talk about what a well-engineered prompt is actually made of. There are 5 elements, and once you understand each one, I bet you'll start seeing them everywhere. Let me show you with an example. We want Claude to write a launch announcement for a project management app called TaskFlow. So we just give it the basic idea and see what comes back. Here we can see it gives us something decent, but it's generic. That is because we gave it no direction. So let's fix that one element at a time. First is role. This tells the model what perspective to take. By default, it's just a general assistant. Let's give it a specific role of a senior social media manager at a fast-growing SaaS startup. See how the tone immediately shifts. It starts sounding like someone who knows how to build hype around a launch. Next is task. Most people think they are writing a task, but they're actually writing a topic. There's a difference. A topic is just the subject. A task tells the model exactly what angle to take. So we ask it to focus on the problem it solves, what makes it different, and why now is the right time. Here we can see the response now has a clear direction and a point of view instead of just describing the product generically. Now, context. This is the background the model needs to make the output relevant. Right now, it's still writing for a fictional audience. So we'll tell it who the real audience is, what their frustration is, and that we have a launch offer running. And just like that, it stops being generic and starts speaking directly to the right person. Next is format. You can tell the model exactly how you want the output structured. So we ask for a launch email with a subject line, 3 benefit bullets, and a call to action. Here we can see it now comes back as a complete, ready-to-send email and not just a block of text. And finally, constraints. These are your guardrails. What to avoid, what tone not to use, what boundaries to stay within. Something as simple as saying no buzzwords, no exclamation marks, and keep it human changes the feel of the output. Now let's talk about technique. Knowing the anatomy of a prompt is one thing, knowing how to structure your prompts for specific situations is another. There are a few patterns that experienced practitioners use regularly that I'm going to teach you today. The first one is few-shot prompting. When you just ask the model something without any examples, that is called zero-shot prompting. It works fine for simple tasks, but when your task has a specific pattern or format you want the model to follow, showing it a few examples before asking is almost always better than just describing what you want. The model picks up the pattern from your examples and applies it consistently. A good use case for this is sentiment classification. Say you're building something that needs to label customer reviews. Instead of just asking Claude to classify a review, you show it 2 or 3 labeled examples first and then give it the real one. The second technique is chain of thought prompting. For straightforward tasks, asking for a direct answer is fine. But for anything that involves reasoning, analysis, or multiple steps, asking the model to think through the problem before giving an answer produces noticeably better results. And the reason is simple. When the model is forced to show its reasoning, it catches its own errors along the way. You also get to see where it went wrong if it does. The third and final tip I'll share with you is repetition. Researchers at Google found that something as simple as copy-pasting your prompt gives you a better result. So while prompting is more of an art than a science, using these tips will help you get more out of your tokens. Here's the problem every developer hits when they start using AI seriously: hallucination. The model gives you a confident, well-written answer that is completely wrong. And the reason this happens is that the model is drawing from its training data, not from reality. It doesn't know your code base, so it fills the gaps with its best guess. The fix for this is grounding. Instead of letting the model rely on what it thinks it knows, you give it the actual information inside the prompt itself: a policy document, a database schema, a code file, a web search tool, or even a research paper, whatever is relevant. Structuring your context also matters. What you place at the top of a long prompt gets more attention than what you bury in the middle. We call this the lost in the middle problem. Separating your instructions clearly from your source material, labeling sections, keeping it organized, even formatting it in JSON, all of that directly affects the quality of what comes back. At scale, these patterns become RAG, retrieval augmented generation, where documents are pulled from a database and injected into the prompt dynamically. But the core idea is the same. Real context goes in and grounded answers come out. So far, everything we have discussed has been around text, but modern AI models are not text anymore. You can prompt with images, audio, and video as input and generate them as output. And each modality has its own prompting vocabulary. For images, you're describing composition, lighting, mood, and perspective. For audio, you're thinking about tempo, texture, and instrumentation. And for video, you're thinking temporally, describing motion, camera behavior, and how the scene evolves over time. The gap between a vague prompt and a precise one is just as wide in these modalities as it is in text. But even though the vocabulary is different, the skill remains the same. Where prompt engineering starts feeling less like a chat skill and more like actual engineering is where you add tool use and agents. When you build AI systems that connect to external tools, say a web search, a code executor, or a database, the model needs to know more than just what to do. It needs to know when to reach for a tool, which one to use, and what to do with the result. All of that logic lives in the prompt. You are now essentially writing a decision framework. And when you go one level further into agentic systems, you're not writing a single prompt anymore. You are designing a loop. The model gets a goal, makes a plan, takes an action, observes what happened, and then decides what to do next. That cycle repeats until the task is done. Your prompts in an agentic system are the architecture of that loop. How the model breaks down a goal, how it decides what counts as done, how it handles unexpected results is all prompt design. The more capable the agent, the more carefully that architecture needs to be thought through. So we've covered a lot: anatomy, techniques, grounding, multimodal, agentic systems. This is a solid foundation and most people never get this far in how they think about prompting. But everything we covered today is still one person, one prompt, and one environment. The moment you take this into a real team or a production system, a whole new set of challenges show up. For example, when multiple engineers are working on the same prompt simultaneously, you need versioning. Treating prompts the same way you treat code. Tracking changes, rolling back when something breaks, and managing prompt state across a live system. Then there is prompt injection. This is where malicious content inside your data or environment hijacks your agent and overrides its instructions. The more capable your agent, the more serious this threat becomes. And then there is evaluation. How do you actually know if your prompt is performing well across hundreds of different inputs? How do you check for consistency, catch edge cases, check for bias? These are not nice to haves. These are things that separate a prompt from one that works in a demo from one that holds up in production. And then there are advanced reasoning techniques that we did not get into, like program of thought and model parameters like temperature that give you direct control over how creative or conservative the model is. All of this is covered in detail in our prompt engineering course on Educative, which goes from fundamentals all the way to production practices. The link is in the description. If any of this made you want to go deeper, check it out.